Oh crap, I'm about to hit this guy. Now's a good time to use my dynamics knowledge and apply it to this real world situation. I wonder how fast I'll be going after I hit this guy. Let's assume no loss of energy to the surrounding and that momentum is conserved. That means at point 1, the mass of the car times the velocity of the car plus the mass of the man times the velocity of the man also at point 1 equals the mass of the car times the velocity of the car at point 2 plus the mass of the man times the velocity of the man at point 2. If I'm going 25 miles per hour, which is also 36.6 feet per second, and he isn't moving, and my car weighs 3,000 pounds and he weighs 145 pounds, 3,000 times 36.6 plus 145 times 0 equals 3,000 times the velocity of the car at point 2 plus 145 times the velocity of the man at point 2. This simplifies to 109,800 equals 3,000 times the velocity of the car at point 2 plus 145 times the velocity of the man at point 2. Two variables.
The coefficient of restitution is 0.5.
If I assume that the coefficient of restitution between my car and the pedestrian is 0.5, then I can set up a system of equations to determine both of our final velocities. So, given E equals the velocity of the man at point 2 minus the velocity of the car at point 2 divided by the velocity of the car at point 1 minus the velocity of the man at point 1. Applying what I already know, 18.3 equals the velocity of the man at point 2 plus the velocity of the car at point 2. I can then multiply this by negative 145. That allows me to combine this equation with the first equation found. Now I can solve for both velocities. After combining the two equations, I get the velocity of the car at point 2 to be 34.1 feet per second, which is also 23.25 miles per hour. Then I can substitute that value into the previous equation and get the velocity of the man at point 2, which is after the collision. Solving for this, we get the velocity of the man at point 2 to be 51.7 feet per second, or 35.25 miles per hour. I swore I would be so proud of my dynamics knowledge.
I hope that the car doesn't run me over. How far will the car and I travel after collision? Well, since I am always prepared, I know that the coefficient of friction for most clothing is 0.45, and the coefficient of friction of the tires is 0.75. I can calculate the distance the car and I will travel after impact. Since I am always prepared, I know that the coefficient of friction for most clothing is 0.45, and the coefficient of friction of the tires is 0.75. I can calculate the distance the cars and I will travel after impact. Using the distance formula, distance equals velocity of point 2 divided by 2 times coefficient of friction times gravity. For the car, that means 57.1 divided by 2 times 0.75 times 10, which means 3.8 feet. And for me, that the distance is equal to 34.1 divided by 2 times 0.45 times 10, which means equals 3.8 feet. Well, darn.